Imagine this. You're standing anywhere on Earth, you pull out your phone, and within seconds, it tells you exactly where you are. No wires, no maps, no asking for directions, just a little blue dot that knows your location with remarkable precision. We've gotten so used to it that we barely think about what's happening behind the scenes. But the truth is, GPS, the Global Positioning System, is one of the most incredible pieces of technology humans have ever created. And most people have no idea how it actually works. GPS. GPS is made up of a network of satellites orbiting high above our planet. This network is called the GPS constellation. At any given time, there are at least 24 active satellites, and today, usually around 31 in operation. They are positioned so that no matter where you are on Earth, at least 4 satellites are always visible from your location. Each satellite constantly broadcasts 2 critical pieces of information: its exact position in space, the exact time the signal was sent. Your GPS receiver, whether in your phone, your car, or an airplane, listens to signals from multiple satellites. Because radio signals travel at the speed of light, your device can calculate the distance to each satellite by comparing the time the signal was sent to the time it was received. With one satellite, all you know is that you're somewhere on a giant sphere surrounding it. Add a second satellite, and those spheres intersect in a circle. Your possible location gets smaller. Add a third, and that circle shrinks to just 2 points. One of those points is usually impossible, like far out in space, so it's eliminated. A fourth satellite not only pinpoints your exact spot, but also corrects any timing errors in your device's clock. This process is called trilateration, and it relies completely on incredibly precise timekeeping. Each GPS satellite carries multiple atomic clocks, which are accurate to within a billionth of a second. If the timing were off by even 1 nanosecond, your calculated position could be wrong by nearly 30 centimeters. If it were off by 1,000th of a second, your location could be off by hundreds of kilometers. Now, here's where it gets even more fascinating. GPS actually depends on Einstein's theory of relativity. 2 things happen at the same time. According to special relativity, moving clocks tick slower. GPS satellites orbit Earth at about 14,000 kilometers per hour, so their clocks run a little slower than clocks on the ground. According to general relativity, clocks in weaker gravity tick faster. GPS satellites are about 20,200 kilometers above Earth, where gravity is weaker, so their clocks run a little faster than ours. These 2 effects don't cancel each other out perfectly. In fact, the difference makes the satellite clocks tick about 38 microseconds faster per day compared to clocks on Earth. That tiny difference might sound like nothing, but without correction, GPS positions would be off by around 10 kilometers every single day. To prevent that, GPS systems constantly apply relativity corrections so your location stays accurate. The satellites face other challenges too. Their signals must pass through Earth's atmosphere, which bends and slows them slightly. Reflections off tall buildings or mountains, called multipath errors, can also cause false readings. Engineers use advanced models and ground-based reference stations to fix these issues and keep GPS working smoothly. And here's something most people don't realize. GPS isn't just for navigation. The precise timing from those atomic clocks is used to synchronize financial transactions, stock market trades, cell phone networks, and even the power grid. If GPS timekeeping failed, many systems we rely on daily would start breaking down within hours. While GPS is operated by the United States, it's not the only system in the world. Russia runs GLONASS, the European Union operates Galileo, and China has Beidou. Many modern devices use signals from all of them for greater accuracy and reliability. So the next time you open your Maps app, remember, it's not magic. It's dozens of satellites in high orbit, atomic clocks ticking with unbelievable precision, Einstein's relativity keeping time in check, and complex math happening billions of times per second. Also, you can find your way to the nearest coffee shop.